Another example that we can solve is let's say we have 0.822 mole of sulfur trioxide in 1 liter container at 600 K, and we see that 36.7% of the sulfur trioxide has decomposed when equilibrium is established. So we started with 100% of sulfur trioxide, and at equilibrium we find that 36.7% of the sulfur trioxide has decomposed. So this is the equation for this reaction: 2SO3 to 2SO2 and O2. So there are two questions that we need to deal with. First, calculate the equilibrium concentration of the species in this reaction. So what we mean by species is the SO, sulfur trioxide, sulfur dioxide, and oxygen. Second, determine the Kc of this reaction. So how do we approach this problem? First, what you need is to have the reaction equation. You need to show your reaction equation there with all the coefficients necessary. Then think about the values. So from the equation, we were given the number of moles of sulfur trioxide as 0.822 mole, and the volume that we have is 1 liter. So immediately we can calculate the molarity by number of moles per 1 liter, which comes to 0.822 molar. So this is our initial molarity of the sulfur trioxide, or the initial concentration of sulfur trioxide. Now, if we let the change in concentration be x, so we can just decide, alright, let the change in concentration be x. What does it mean? If we use our equation again and say the change in concentration is x, so we come up with a table like this one. We say, alright, what is my initial concentration? So the initial concentration of sulfur trioxide is given here. So initial concentration of sulfur dioxide is 0.822. This is our reactant. Initially, we did not have products, so the initial concentration of our products is 0.000. Then for oxygen, also 0.000. What about the change? We have said that the change in concentration should be x. Now what do we have? If you look at the stoichiometry here, although the change in concentration is x, if you look at the stoichiometry, we have 2 here. So if we are reacting 2 of sulfur trioxide, it means the change should be 2x because of the 2 here. But here we are consuming the sulfur trioxide, so we are reducing the amount of sulfur dioxide. That's why we need to put a negative for the reactants. Here we are making 2 molecules of sulfur dioxide, so the change should also be 2x, but now we are adding to the product, so it should be plus 2x. And here we are making 1 molecule of oxygen, so in this case the change is x because it is just 1 molecule of oxygen. So we put here plus X because it is a product. So in the end, when you subtract 0.822 minus 2x, this is what we should have here. 0, 0 plus 2x, this is what we should have. 0, 0 plus x, this is what we should have. That's how you set up this problem. Now, if we have to plug in the numbers, since the number of moles of SO3 is 0.822 and our volume is 1 liter, so we know that the initial molarity of our SO3 is 0.822 molar. But we have been told that 36.7% of sulfur trioxide is decomposed. So you want to make this percentage to become the number of moles. So if we start with 0.822 moles, what is 36.7% of that? So the 36.7% of 822 moles is 0.302 moles. So that is the change in the number of moles. But remember, in this case we are not dealing with the number of moles, we are dealing with the molarity. So you need to change this one to molarity. So in terms of molarity, the change should be 0.302 moles per 1 liter. Remember, we still have 1 liter of solution. So our change in molarity is 0.302 molar. Now these ones are our initial molarities. This is the change. So minus 0.302 is my 2x. So instead of 2x here, this is what we have, because that's the change in SO3. But we also said that the change in SO2 here is 2x. So it's the same, this one and this one, only that this one is a plus. We are adding the same amount of moles, or the same concentration change here is equal to the same concentration change here. But here is minus 0.302, here is plus 0.302. Why are they equal? Because both of them have the coefficient of 2. What about oxygen? How much change in concentration is happening in oxygen? Here we have 1 oxygen. So whatever we get here between these two, we need to half it, because the ratio between sulfur trioxide and oxygen is 2 to 1. So instead of having 0.302 here, we'll have 0.151 here. So after the subtraction and additions here, this will be our equilibrium concentration: 0.520, 0.302, 0.151. How do we move from here? We draw our equation again, and these ones are our equilibrium concentrations. The next step is just to write the Kc of this reaction using the coefficients, and then plug in the numbers. When you plug in the numbers, you get your answer here. So you can work on these two assignments. This one is the first one. If you want to write it down, just stop the video and write it down, the exercise that is, and this is the second one. Thank you. Also, if you want to write it down, just stop the video and write everything down and then do it. Thank you.